Okay, this video is for the spheres, for those of you that missed lesson today and tomorrow, well, March 23rd and March 24th. This is the honors lesson for March 23rd and 4th. For standard, it's the March 25th lesson. So the topic is spheres, and this is still the surface area of volume unit, so we're in unit 11, continuing on with those topics, but we're doing circular figures now, so spheres. A couple parts of the sphere that are important to know. The diameter, just like on a circle, is the segment that runs through the whole length of the sphere. The radius would be any segment connecting the center to the end of the sphere. This point here is still called the center, just like it is on a circle. And this ring here is the great circle. So if you were to cut it here, that would divide it into two hemispheres, or two half spheres. So this is the great circle. Okay, and the formulas for this, we're going to be able to use these formulas on the formula sheet. So the volume of the sphere is 4/3 pi r cubed. So the volume formulas are given for you. Well, the formula for volume and surface area is given to you on the side here. So you're just really applying this formula. And a lot of people get tripped up when there's a 4/3, but really that just means 4 divided by 3, or that you take everything, like multiply all this stuff and times it by 4, it's essentially in the numerator, and then divide the whole thing by 3. So for each of these answers for the problems, I want the answers in terms of pi. Okay, remember that's right before you multiplied through by pi, and then also to the nearest hundredth. Okay, so the volume, again, we're going to take this formula. So volume is equal to 4/3 pi r cubed, and we're just going to substitute in the radius that they've given us. So the radius is 7. So for PEMDAS from Algebra 1, remember we're going to do exponents first, and then we'll do multiplication. Multiplication is commutative. It doesn't matter what order you do it in. So we can do, in our calculator, 7 cubed is going to be on the in-class calculators. You're going to hit second and then 1, because it's the button in green right above this. So second 1 gives me 7 cubed is 343. The other way to get that is just to multiply 7 times 7 times 7. Okay, then we're going to times it by, we're going to ignore pi, so we want the in terms of pi answer, so we times it by 4, and then divide it by 3. Okay, it gives us this decimal. To get an exact answer for the in-class calculators, you're going to hit second, F to D, which stands for fraction of decimal, so the arrow above it is FD, fraction of decimal. So that gives us the answer going from decimal to improper fraction, or to mixed number. And then we hit second ABC to go from mixed number to improper fraction. So if we type all of that in, we get 1372 over 3 pi. And when we multiply, that's the answer in terms of pi, so that's one of the answers. And this is inches cubed because we did inches times inches times inches, so we did inches 3 times. Okay, and then timesing that by pi, we get 1436.76 inches cubed. So that's the second answer. Okay, number 2 is the same formula, but they give us the diameter this time. The formula doesn't have diameter in it, so we need to figure out what the radius is. So if the diameter is always the full length all the way across, the radius is always half of that. So the radius would be the length from here to here. And to get that, we're just going to divide the diameter take the diameter divided by 2. So 16.5 would be our radius. Okay, so if we do 16.5 and we cube it, we get this large number. Then we times that by 4 and divide that by 3. We get this number. So because it doesn't continue past, this is an exact number. So we don't have to actually get the fraction form. because it's an exact number, we can leave it like this with pi behind it. So that's my answer in terms of pi, and the units was centimeters, so centimeters cubed. And if I multiply 3 by pi, then I get 18816.57 centimeters cubed. Okay, so that's it for volume. So volume, you're just applying this formula. Again, 4 divided by 3 just means, 4/3 just means on your calculator you can do 4 divided by 3 and then times everything else. Or you can do 4 fraction 3 with a fraction bar ABC. Sorry, there's a glare on there. 4 fraction bar 3 and then times your other stuff. So timesing it by 16.5 to the 3rd power. Okay, or you can multiply 4 times all of this stuff and then divide by 3 at the end. So I can do 4 times pi times 16.5 cubed and then divide all of that at the end by 3 to get this number. It's a little bit of different options for 4/3, but don't let it throw you off, just a fraction. Okay, find the surface area of each sphere below. The surface area formula is given here is 4 pi r squared. So we're just doing the same thing we did before, but we're applying it to a different number. So we need the radius, and we're just plugging it in. So 2.8 squared this time and not cubed times 4, 31.36 pi, and actually timesing it by pi, 98.52, and these are meters squared because we only had radius times radius, so radius squared. Okay, when we're looking at number 5, hemispheres, I'm going to skip 4 and let you do that one. But we're still finding the surface area of the full sphere. For 5, we're looking at the volume of a hemisphere. So the volume of a hemisphere formula is given here. So it's half of the volume of a sphere. So that makes sense. If you take half of the sphere away, then your volume just gets cut in half. So originally our volume for a full sphere was 4/3 pi r cubed. If we want a hemisphere, we just divide that by 2. Okay, really dividing by 2 really means multiplying by the reciprocal, so that this would look like this. And the numerator still has 4 times 1, it's just going to give us 4. 3 times 2 is going to give us 6 pi r cubed. And then 4/6 can be simplified because both of those are divisible by 2, so we can write that as 2/3 pi r cubed. So that's how we derive this formula from half of the volume of a sphere. Okay, and now we're just doing what we did before and plugging that in. Okay, our radius is 5, so we're just substituting a 5 in here and evaluating. Five raised to the 3rd power times 2 divided by 3 gives me a decimal. So to get back, I can just hit second arrow. Gives me an improper or mixed number. So to get an improper fraction, I want to just do 250 over 3 pi. Timesing that by pi, I get 261.8 kilometers cubed. On the back, there's another one for volume. Then you have surface area. So surface area of a hemisphere, formula is on the front. So if you'll notice, it's not just half of the surface area of a full sphere. And the reason that is because the surface just changed if you cut the sphere in half. So if you take the sphere and cut it in half, not only does it have the bottom part of the sphere that it has, but it also has an extra circle here. So again, this sphere, the surface area means the area on the surface. So the surface has this half of the circle, so we still have the 2 pi r squared coming from that part. And then it has an additional surface, this circle, which is another pi r squared, so we end up with 3 pi r squareds. So again, if we take half of the surface area, so the surface area for a full sphere is 4 pi r squared. We take half of that because we have half of the sphere, but we also need to add to it. We created a surface when we cut it in half. We created an extra circle surface that wasn't there before, so we need an extra circle area. Well, 4 divided by 2 is just going to give us 2 pi r squared. And this is understood to be 1 pi r squared, so we have a total of 3 pi r squareds. Okay, so then we're just applying this radius to the, inputting this radius into the formula. So again, this is still the radius because if the rest of the circle was there, the diameter would continue past this. So it's still from the center. Anytime it's from the center to the edge, it's the radius. So this is 3 pi 14 squared. So I want to do it in terms of pi first. So 14 squared times 3 is going to give me 588 pi. And then actually timesing that by pi, 1847.26. And the units for this was yards. So yards squared since it's area. Okay. So remember on all the ones I'm not doing, they typically the diameter, you need to find the radius because the radius is in the formula, but diameter's not. But other than that, it's just like the ones we've done. For number 9, find the volume of a sphere with a great circle area of 201.06 square inches. So the volume of a sphere with a great circle area. So the great circle area means like if you were to cut it, what the area of that circular piece would be. So that's area, that means what I have shaded is 201.06. So for volume, what we need is to find the volume of a sphere is 4/3 pi r cubed. That formula is just from the front. It's also on the formula sheet for the EOC. Well, if you were to take the EOC. So 4/3 pi r cubed would be our formula, so we need to figure out what the radius is. So if we know the circle's area, and we know the area of a circle formula is pi r squared, we can work backwards. So we want to start with this formula, work backwards to solve for the radius, and then plug the radius into this formula. Okay, so you can pause it and do that if you already are pretty confident you can do that on your own. But I'll go through the steps on here in case you need it. So the area is given, so we plug that in for A. We don't know R, so we just have 201.06 equals pi r squared. So 201.06 divided by pi gives us about 64. And then we would square root both sides to get r by itself. So it's around 8, because if we rounded it, it would be 8. Alright, so the radius is 8, so that's where we're going to come in over here and plug in. And then we're going to evaluate that. So we cube this, times it by 4, and divide it by 3. Okay, if I had done it just with 8, I could get a better answer, like a more exact answer, but because I left it as 7.99, that's why it's off. So let's do it with 8. Okay, so this gives me the exact answer. So if I hit second arrow and second ABC, it's 2048/3 in terms of pi. And this was in inches. Okay, and then timesing it by pi. In to the nearest tenth, it's going to be okay. 10 is the only one on this that asks for a surface area of a cone. We have not done surface area of a cone because it's a little involved and it wasn't part of the standards. But because this handout has it on here, I'll go ahead and give you the formula for the surface area of a cone. So the surface area of a cone is pi r squared, and that's for the base of the cone. And then this piece has a formula of pi RL. Okay, the derivation for that is a little lengthy. I can go through it if you care at the end of the video, so you don't have to watch that part for this part of the video. But if you were to draw this net out, like if you were to cut it and make it a two-dimensional figure, this is what the cone's net would look like. So this area is the pi RL part. This is related to arc length and sector area. So this would be a sector area we're looking for, and it's arc length. But again, this is what you need to know for a cone. Okay, but on the cone, there's one part of this formula that's not on the surface, so you need to figure out which of these is not on the surface. So out of the cone, is it this part or this part that's not on the surface in this picture? Okay, if you said this part, you're right. So this part's not on the surface, so we would get rid of that part because it's not a part of the surface's area. And then on the hemisphere, we need the surface area of a sphere, but we only need half of it. Okay. Normally the surface area of a sphere includes the circular piece here, but the circular piece is not on the surface, so that's why it's only 2 pi r squared instead of 3. So we're going to be adding pi RL and 2 pi r squared for the surface of this funky figure. Okay, where L is the slant height. So this distance here is your L. It just stands for slant height. Okay, so if I plug in, it's going to be pi. The radius is, the diameter is 9, so the radius would be half of that. Okay, then you can evaluate. Okay, so that answer for 10 should have been, I'll just write it out, 311.02, or in terms of pi, 99 pi. Okay, and then lastly, I'll let you figure this one out because it's kind of fun to try some application ones on your own. So I'll give you a second to read it. So first you would need to figure out if you're doing surface area or volume. Okay, it should be volume because you're figuring out how much something can hold, so filling up or how much something can hold is all volume. So you would be doing the volume of two shapes. You need to figure out the volume of a cylinder and the volume of a sphere. On this handout we haven't done any volume of a cylinder, so let me just remind you that the volume of a cylinder is equal to the area of the base of the cylinder, which is the circle, times how high the cylinder is. So the capital B here is a circle. So you do the area of the base of the circle, so the pi r squared is the area of the circle. Find out that, and then times it by how high it is, because you're basically filling the bottom up, taking the bottom and covering it, and then filling it up. And then you would also need the volume of the hemisphere. Okay, but I'll let you solve that, and I'm going to flash the answers so that you can see if you got everything right.